Alrighty, welcome to another video. This one is on the dot product again, projecting forces onto a member. And I've kind of created this problem in response to your last gift, which when I kind of noticed that a lot of you are sort of having a little bit of trouble with force projections. So, in this problem we're asked to find the force acting on the member CD from the 800 Newton force. So we're trying to find the amount of this force acting on this member C and D. So before we get started, I'm going to kind of try to write out a little bit of a procedural analysis for this. So the first thing we're going to do is we're going to find the coordinates of C, of point C, and we're going to do that so we can go ahead and get our unit vectors for CD, and then we're going to get a unit vector for CE. So then we can go ahead and get the components of our force that's acting in this direction. So then we'll get the components of the force. And then after we do that, we'll be ready for the actual dot product part. Which is then the force acting along CD, which is in the end what we're really looking for. So let's go ahead and begin with part number one. Scroll down a little bit. So numero uno. So what we need to do is we need to find kind of the coordinates of this in our XYZ plane. So what we're going to do first is we're going to go ahead and figure out what it is from A to B, because C is basically in the middle of that. So from A to B, from A to B, we're going from, this is our origination, this is our destination. So if we all remember just how to basically to get this, we're going to go from our destination minus the origination. So we come up with, well, before we do that, let's go ahead and put some coordinates on here. So at point B, we have 2 in the X, looks like 6 in the Y, and then 0 in the Z. Then up here at point A, we have 3 in the X, 0 in the Y, and 5 in the Z. All the other points and coordinates are already given, so now let's go ahead and find AB. So we're going to have our destination minus our origination, so that's going to be a 2 minus a 3. That's in the I direction. And then we're going to have our destination minus our origination, so that's 6 minus 0. That's in the J direction. And then we're going to have again our destination minus our origination, so that's a 0 minus a 5, and that is in the K direction. So looks like we have a -1 in the I, a 6 in the J, and a -5 in the K. So, but we're after point C, and point C is just going to be half of this because it's in the middle of this member AB. So what we're going to do is we're going to basically take AB and then just divide it by 2. So we end up with a -0.5, a +3, and a -2.5. This is in the K, this is in the J, and this is in the I. Now keep in mind that this is relative to AB. So we need to kind of think about this a little bit and figure out relative to our original coordinate system, which starts over here, where this is going to be located, because all of our other points are defined relative to this original coordinate system. So if we look at so you can kind of do this by, if you start from A and kind of subtract off all of these points, then you'll get a idea of where point C is. So from A to C, from A to C, it looks like this, that we're going to go back 0.5 in the X. So we're just going to go back, and you can kind of see that if you go back 0.5, then you're at 2.5. So this one's at 3, this one's at 2. Half of that's going to be 2.5. And then if we go 3, 3 from here, it's basically going to be the midpoint of this in the y direction. So, well, that's just basically going to be it. 3. And then this one's going to be the same because this is half of this 5. So this is going to be a 2.5. And you can see that this makes sense that they're all positive because we're in here in the first, it's not really a quadrant, it's more like a octant since we're in three-dimensional space. Hextant maybe, I'm not really sure. So now we have our point C. So let's go ahead and label our point C as 2.5. Let me do a little bit farther up. Oh, it did not go the way I anticipated. So we have 2.5, we have a 3, and another 2.5. So that's step 1. So now we're ready for step 2, which is get our unit vector CD. So step 2, get our unit vector CD. Unit vector CD. Well, I guess I should write it out a little bit more. U hat CD. Anything with a hat is a unit vector. So this is, fairly straightforward. You guys should be getting fairly comfortable with this. So we have it's going to be the same thing of destination minus origination. So we have our destination right here, and our origination is this point C, which is all this up here. So we're going to have a -3 minus a 2.5. Then we're going to have a 2 minus a 3. And then we have a 1 minus a 2.5. And all this is going to be over the resultant of each one of these. So we'll have the square root sum of squares of a negative, well, yeah, we'll go negative 5.5 quantity squared plus a -1 quantity squared plus a -1.5 quantity squared. And when you square all these negatives are going to go away and everything will become a positive. So this is actually equal to 5.787. And just kind of backtrack a little bit and show you where all these came from. See if I can get them all both in the same window. There we go. So destination -3 minus the origination, which is 2.5, destination, which is 2, minus our origination, which is 3, and then the destination minus your origination. So now we're ready to write out our unit vector CD. So our u hat CD is going to be equal to negative 5.5 divided by 5.787. This is in the I direction, plus a negative 1, 5.787. This is in the J direction, and a negative 1.5, 5.787. This is going to be in the K direction. So let's just go ahead and do a little bit of math and figure out what all these are going to be and put it in a nice point format, I guess. So u hat CD is going to be equal to negative 0.950, negative 0.173, and a negative 0.259. Whoops, not parenthesis, need a whatever that thing is. Alright, so that's step 2. We've got our unit vector CD. And if you keep in mind, our overall goal here is to do the dot product, and we're going to do the dot product of F of our force times our force's components. So we're going to need UCE dotted with UCD, and that's going to give us our projected force on that member. So we've got this part, we've got this part. Now we just need to get, wait a minute. Now we've got this part and this part. Now we just need to get CE. So let's go ahead and start a new page. Append to page. And now we are ready for step 3, which is get our U hat CE. Yeah, that kind of rhymed. So once again, we are back into destination minus origination. So we look at our destination down here at point E and our origination up here at point C. And we're going to do the same thing that we did for CD, just kind of apply it to CE. So we have a 7 minus 2.5 plus a 2 minus a 3 plus a negative 1 minus a 2.5, and all that is going to be over the resultants, or the square root sum of squares of all of these. So this turns out to be a 4.5 squared plus a negative 1 quantity squared plus a negative 3.5 quantity squared. And this is going to be equal to a 5.79. You'll notice that these two are a little bit close. I don't want you guys to get confused by that. I didn't really think about that when I came up with the problem. It just kind of worked out to be that way. So our U hat CE is going to be equal to 4.5 divided by 5.79. I direction plus a negative 1, 5.79 in the J direction, plus a negative 3.5 divided by 5.79 in the K direction. And let's go ahead and break it down a little bit farther. Go ahead and get all that math out so we get some nice, even, nicer looking numbers. 0.777, negative 0.17. think that's a 3, and a negative 0.605. Okie doke, that's our U hat CE. So now we're going to come down here and we're going to find step 4, which is the components of the force. So we're just going to take this 800 Newton force, which is just its magnitude, and break it into its X, Y, and Z components. So let's go ahead and do that. Step 4. Get components of force. So, and that's just going to be F dotted with CE, well, U hat CE, U hat CE. So we have 800, going to be dotted with 0.777, negative 1.73, 0.605, arrow, and you're just going to kind of take this and multiply through. This should be fairly straightforward. You guys should be definitely used to this by now because you're going to be using it a lot coming up. So we get our force vector is going to be equal to a 621.985 in the X, a negative 138.219 in the Y, and then a negative 483.766 in the K. That was fairly easy and straightforward. So now that we've got all that, we're ready to come up here to step number 5 and do our dot product once again. And we should be, and that should be it. So we've got all of our components. We've got our force in its component form. We've got our unit vector, CD. And if you look up here, that's all we need in order to get that. So now we're ready for F dot U hat CD. So this is going to be equal, well, bring it down below, this is going to get a little bit large. So we have -622, negative 138, and negative 484, going to be dotted with our unit vector up here. So that is a negative 0.950, negative 0.173, and a negative 0.259. And we'll just we'll break this out so it's into its longer form. So you just kind of take each one of these, multiply them together, and then add it with the other directions. So let's kind of break it out. So we have 622 times a negative 0.950 plus negative 138 times a negative 0.173 plus a negative 484 times a negative 0.259. And this turns out to be a negative 591.045. This is 23.88. And this one over here is a 125.373. Adding all those together, so our F, well, take FCD, the magnitude of it, is equal to a negative 441.791. And if you wanted to go back and figure out the components of that, you could just take this number and do what we did up here to find the components of our force and just multiply it with the unit vector of CD, and that would give you all of the different components of it. So I hope this clarifies things a little bit on the dot product and projection of forces, and I will see you in the next video.